Hello and welcome to listening to the radio.
Okay. Dit, 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 da, 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 dit, dit, dit. So let's break down that sound. It's pretty familiar, right? 3 short bursts, 3 long, 3 short again.
Uh-huh. S.O.S.
Exactly. The universal distress signal, S.O.S. And it's, fundamentally tied to a communication method you might think is firmly in the past. Morse code.
It's fascinating, though, isn't it? How something seemingly old school is still kicking around.
Totally. It pops up in emergencies, even in modern navigation, surprisingly.
Well, it tells you something about the original design, that a system from, nearly 2 centuries ago still has value in the 21st century. It's pretty robust.
Absolutely. So for this deep dive, we're jumping headfirst into the world of Morse code. We're going to look at its interesting history, figure out how it actually works.
Discover where it's still used, past and present.
And really get a feel for the skill involved in mastering it.
And we've got some great source material to guide us. There's a technical paper on a Morse code translator automaton, a really comprehensive manual by William Pierpont on learning and using international Morse code.
Right.
Plus other bits on the history, its evolution, why it's still crucial in modern maritime navigation, and of course the details on S.O.S. and other health signals.
So our mission today, if you choose to accept it, and you kind of already have by tuning in, is to quickly grasp the essentials of Morse code, understand why it stuck around, and maybe appreciate the skill behind it, all without getting bogged down in super technical jargon. Sound interesting?
Definitely. Let's start with the basics then. What exactly is Morse code?
Conceptually, it's pretty simple, really. It's a communication system using short signals, we call them dots or dits, and long signals known as dashes or DAs to represent letters, numbers, punctuation. Think of it like a language built purely on rhythm.
And that rhythm, the sound patterns.
Yeah.
That's absolutely the key to learning it effectively.
Yeah.
Most experts agree. Trying to visually memorize dot-dash sequences, it's way less effective than actually internalizing the sounds.
Mm-hmm. Correct. It's more about training your ear than your eye. And speaking of training, that technical paper, the Automata Traductor, gives us a peek under the hood. It talks about input, represented by the Greek letter sigma.
Which is basically the alphabet, right? The letters you want to send.
Exactly. Then there's the output, gamma, which is what the Morse code translates to all the possible Morse sequences for those letters.
Okay.
And finally, states, S, which are like the different stages in the translation process itself.
And what's interesting there from a technical standpoint is this idea of an automatic translator. It mentions 2 main models. Mealy.
Really?
Yeah, where the output depends on both the current state and the input signal coming in. Think of it like translating on the fly, signal by signal.
Gotcha.
And then there's the Moore model, where the output only depends on the state the translator is currently in. It sort of processes a bit more before deciding the output.
Yeah.
Just different ways a machine can handle that translation.
Huh. Fascinating. Even if we're just scratching the surface, technically. Okay, let's rewind. Where did this system even come from? How did Morse code get started back in the 1830s?
Well, the story goes back to 1832, and the original system Samuel Morse came up with was, quite different from what we use now. It was initially a number-to-word system.
Number-to-word. How did that work?
Imagine having a dictionary where every word had a corresponding number. You'd transmit the number using his code for digits, and the receiver needed the same dictionary to look the word back up. Letters were also assigned numbers for spelling out names or uncommon words.
Wow. Okay, so you'd look up hello, send like 528, and the other guy looks up 528 to see hello. Sounds a bit cumbersome.
It was, which highlights why simpler, direct methods often win out. That's where Alfred Vail comes in.
Ah, Vail. He's the one who really shaped it, right?
Pretty much. In 1838, Vail developed a much more practical code, a purely alphabetic one, using dots and dashes. Though, it's worth noting, early versions sometimes combined letters, which could be a bit ambiguous to listen to, apparently. Easier on paper tape, maybe.
So Vail streamlined it, direct letter for letter, ditching the whole dictionary lookup. But I gather there were still different versions floating around.
Oh, absolutely. The original American Morse code, the one Vail refined, was widely used in the U.S. and Canada right up into the mid-20th century. It had some unique features like internal spacing within some characters and different dash lengths.
Different dash lengths.
Yeah. The word was that American Morse could potentially be faster and maybe required less effort to send, but it demanded more precision from the person receiving it. You had to listen more carefully.
Interesting trade-off. Speed versus clarity, maybe.
Yeah.
So how did we get to the international Morse code that's standard now?
Well, that involved developments in Europe. Around 1847, a German engineer, Friedrich Clemens Gurk, modified Morse's code for a Hamburg to Cuxhaven telegraph line.
Oh.
Girk simplified it. He got rid of those internal character spaces and standardized the dash length. He basically left just two elements, the dot and the dash. This sometimes made transmissions longer, but it arguably required less skill to get the same accuracy. Girke's code heavily influenced what became International Morse.
So a German engineer really helped shape the global standard. That's neat. I also read about some weird early terms for the signals. Iddies and click for dots, umpties and kalunk for dashes.
Huh. Yeah, those likely came from the sounds the old telegraph resonators made. Those devices turned the electrical pulses into audible clicks. So click for a short one, kalunk for a longer one. It was sort of onomatopoeic, right?
You can almost hear it. Click, click, click. Very intuitive for the operators back then.
Exactly. It reflects how they experienced the code through sound.
Okay, so we've got the history down. Now, for someone like me, maybe listening, who's intrigued, what does it actually take to learn and master Morse code? It sounds kind of daunting.
Well, William Pierpoint, in his manual, he compares it to learning a musical instrument, or maybe touch typing. He stresses it's about developing a collection of habits that, with practice, just become automatic.
Habits, automatic.
Okay. And he says the right mental attitude and practicing the right way from the start are crucial.
Like touch typing, where eventually your fingers just know where to go without you consciously thinking, okay, index finger, T. Is it like that with Morse?
Precisely. At first, you're learning very consciously, letter by letter. D means S, da means T. But gradually, with enough practice, your subconscious takes over. The real breakthrough moment is when you stop consciously processing each dit and da and just instantly recognize the complete sound pattern of the character. Pierpont calls it that aha moment when the letter just pops into your head from the sound. No intermediate translation needed.
That sounds like a goal worth aiming for. But I also read about something called the Morse bog. Sounds unpleasant.
It can be frustrating. The Morse bog, or getting stuck, often happens when learners try to visually translate the dits and das in their head, instead of just recognizing the sound patterns directly.
How does that work?
It's like, hey, your conscious mind is fighting to translate, okay, that was dit da, that's A, while your subconscious might have already recognized the D-da sound as A. It creates this mental bottleneck, usually around 7 to 10 words per minute, because you're doing this two-step translation. Sound to visual dots dashes, then visual to letter.
So the key is cutting out that middleman. Go straight from sound to meaning. How do you actually train your brain for that?
Effective techniques really focus on auditory immersion right from the get-go. Hear the sound pattern associated directly with the letter. Don't think that did the da, think you. Repetition is obviously vital.
Makes sense.
One recommended technique is head copying, just listening without writing anything down, trying to recognize and understand. There's also a mention of a two-way word game for building recognition speed by hearing and mentally repeating words.
Like echoing it back in your head? Any other tips for getting over that learning curve?
Practicing with familiar words and connected text definitely helps your brain anticipates and recognizes faster. And then there's the Farnsworth method.
Farnsworth? What's that?
It involves sending the characters themselves at a fairly high speed, so you learn their proper sound shape, but with longer pauses between the characters. It gives your brain time to process each character's sound before the next one starts. Apparently, Thomas Edison suggested something similar way back in 1902.
Oh, interesting. Like hearing the whole word clearly, even if spoken slowly. And I saw mentions of Candler and Koch studies.
Yeah, those researchers emphasized learning by sound at a sufficient speed. They suggested around 12 words per minute initially, specifically to grasp the whole acoustic pattern, the gestalt of each character from the start.
Gestalt, the whole shape of the sound.
Exactly. They also pointed out how trying to learn visually first can actually interfere with auditory recognition later because they seem to use different memory banks in the brain.
Fascinating how our brains handle different inputs. Okay, so learning Morse is about training the ear, building those direct sound-to-letter pathways. But is this skill still actually relevant in our super-connected digital world?
Surprisingly, yes.
Yeah.
One area where it's still quite critical is modern maritime navigation.
Maritime. Like ships. You're kidding.
Nope. It might seem archaic, but Morse code signal lights are still used as a reliable backup communication system on ships.
Well, it's code lights. Why wouldn't they just use radio or satellite comms?
Well, think about situations where electronics might fail, or you need really clear, unambiguous communication over relatively short distances, maybe ship to ship in close quarters. Lights are a direct visual medium. Plus, the tech's evolved.
Yeah, so
Modern Morse signal lights often have adaptive intensity controls.
adaptive intensity.
Yeah, they automatically adjust the brightness based on conditions. If it's foggy or raining, the light gets brighter for visibility. At night, or in clear conditions, it dims down to avoid glare and save power. There's an example mentioned, the CXD7 signal light.
That's actually pretty smart, adapting to make sure the message gets through. And of course, we have to mention the most famous Morse signal of all, S.O.S.
Right. The International Distress Signal, S.O.S, is universally recognized. And you can send it not just with light flashes, but with sound, too, like a whistle. Or even visually, using a mirror as a heliograph. Body movements, signals on the ground. The typical response signal, by the way, is 3 dashes, the letter O.
So a simple pattern of dits and dahs can literally be a lifesaver? That's powerful. I even read you can potentially communicate with the International Space Station using ham radio transceivers. Could Morse be part of that?
While most ISS communication is voice and digital data, amateur radio operators sometimes do use modes like CW continuous wave, which is the method for transmitting Morse to make contact. It's particularly good in weak signal conditions because it cuts through noise well. Just another example of its versatility.
Okay, we've talked about receiving. What about sending Morse code? I understand each operator develops a unique fist. Sounds a bit like handwriting.
That's a great analogy, exactly. Every operator develops a unique fist or characteristic style in their Morse transmission. It's those tiny, often unconscious variations in rhythm, spacing, and character formation.
Like a signature.
Precisely. An experienced operator can often recognize another operator just by their fist, sometimes even before they formally identify themselves. It's like recognizing someone's voice.
So it's not just about hitting the right dits and dahs, it's the flow, the feel of it. What about the actual mechanics of sending? Using a key?
Yeah, the Pierpont manual really stresses proper technique with a hand key. The main action should come from the wrist, like a hinge, not just the fingers tapping. And keeping the hand, wrist, and arm relaxed is important to avoid fatigue and ensure smooth sending.
And there are different types of keys, right?
Yes, there's the basic straight key, the up and down kind most people picture. Then there's the side swiper or double speed key, which uses side-to-side motion. And the semi-automatic key, often called a bug.
A bug. That's a funny name. What's special about that one?
The bug, like the ones made famous by Vibroplex, is semi-automatic. It has a pendulum mechanism. You push the paddle one way, and it automatically generates a string of dits. You push it the other way, and you manually form the dahs.
Whoa!
It takes some skill to coordinate the dits and dahs smoothly, but it allows for potentially faster sending than a straight key.
Seems like there's a real art to sending, well, just like receiving. And legibility is the main thing, yeah. More important than just raw speed.
Absolutely, number one requirement. If the person on the other end can't understand you, speed is pointless. Rushing, maybe shortening the spaces between characters or words, especially familiar ones, can make copy incredibly difficult, particularly if there's noise or interference.
Better to be clear and slightly slower than fast and garbled. Got it. Now, speaking of speed, I know there are some seriously skilled Morse operators out there. What kind of speeds are we talking about, and what does it take to get to that level?
Well, skills progress, from beginner up to what some call super expert. And as reception becomes more automatic, the enjoyment really increases. Historically, Ted McElroy was a long-time speed champion, hitting some incredible speeds.
How fast?
Records are tricky, but significantly faster than conversation. Today, you have groups like the chicken fat operators, or CFO in the US. These are high-speed enthusiasts who enjoy long chats, sometimes between 40 and even up to, 100 words per minute.
Wow, 100 words per minute. That's faster than most people talk. How do they even comprehend that?
At that level of expertise, they're not hearing individual letters anymore. They're hearing whole words, even short phrases, as single sound units. It's an amazing level of subconscious processing. They can often copy several words behind the transmission.
It's like their brains are just wired differently for it after all that practice. Okay, one last thing. I noticed mentions of shortcuts and conventions in Morse. What's that all about?
Yes. Especially in the early days of wireless telegraphy, when speeds were slower and bandwidth was precious, operators developed shortcuts to speed things up. This includes using Q signals.
Q signals?
Yeah, 3-letter codes starting with Q that stand for common phrases or questions used in radio communication. Like QTH means my location is, and QTH means what is your location? Saves sending the whole sentence.
Like texting abbreviations almost?
Kind of. They also use standard abbreviations for common words like AGN for, again, TNX for thanks, WX for weather, and often omitted unnecessary words, just like in a telegram, to keep things concise.
So it was like developing a shorthand for the language of dits and das. Makes perfect sense for efficiency.
Exactly. Especially crucial when every second counted or conditions were tough.
Well, this has been a genuinely deep dive into Morse code. We've covered the history, how it works, the skill in learning it, its modern uses, even the unique voice of each operator's fist. It's definitely more than just some dusty relic.
To sum it up, yeah, we've seen Morse as fundamentally an auditory skill, as its rich history, and it still holds relevance, particularly in areas like maritime safety. The learning process itself is fascinating, that journey to automaticity, and each operator really does develop that unique signature.
So here's a final thought for you listening. In a world just saturated with instant digital communication, texts, emails, video calls, what is it about this seemingly ancient method that still captivates and connects people? You know, from emergency responders to ham radio enthusiasts, even astronauts sometimes.
That's a great question.
What might the inherent limitations of Morse code, the slowness, the focus it requires, ironically contribute to the depth, maybe the meaning of the communication itself?
It forces a different kind of attention, doesn't it? A focus on rhythm and sound, a deliberate pace. Maybe there's a unique connection formed through that shared, focused effort, something beyond just the information exchanged.
Definitely something to mull over. If you want to explore more, maybe look up the history of telegraphy, listen to some examples of different Morse fists online, or perhaps check out amateur radio communities. There's a lot more out there on this enduring skill. Thanks for joining us on this deep dive.